Now listen to a conversation between a student and a professor.
Hi, Professor. Do you mind if I talk to you for a minute?
Sure, Carla. What's going on?
Well, as you know, this has been a really difficult class for me, and I'm really nervous about the final coming up. I'm scared I'm going to fail this class, but I have to pass, or I'll have to take an extra class next semester, and I know that would be difficult. I was wondering if you could help me prepare or figure out a way to at least make sure I'll pass.
Yes, I've noticed this class hasn't been easy for you. I'm glad you came to me because the last thing I want is for any of my students to fail the course. What have you been doing to prepare for the final?
Well, I'm studying in the library whenever I can, but I feel like I just don't understand the information. I'm only taking this intro to biology class because I need to fulfill my science requirement. I'm a French major, and science just doesn't make sense to me. I'm really scared I'm not going to do well on the final. Is there any way I could do some extra credit to help my grade?
I'm sorry, Carla, but there will be no opportunities for extra credit. If I let you do something, I would have to let everyone in the class do it.
Oh, okay, well, I understand, I guess.
Why don't you see if you can study with some other students in the class? I'm sure Martin or Sarah would be willing to help you. They seem to have an excellent grasp on the material.
I could. I kind of feel bad asking. I know Sarah is in the student government and Martin is on the soccer team, so I feel like they're both really busy.
Well, if you don't feel comfortable working with them, you could always go to the student center and have them help you find a tutor. You would have to pay, but it's really cheap since they are student tutors and subsidized by the school.
I guess I could do that. I really can't afford to fail this class, so I think I'm going to have to invest in a tutor.
I know many students who have done well after working with one of the student tutors. If you decide to go that route, I'm sure you will benefit as well.
I hope so. Thanks, Professor.
Of course, Carla. Good luck.
Now, answer the questions. 1. What problem is the student having? 2. Why does Carla mention that Sarah is in student government and Martin is on the soccer team? 3. Why does the student say she is taking this class? Four. What does the professor suggest Carla do? Select 2. Five. What is the professor implying when he says that Martin and Sarah have an excellent grasp on the material? Now listen to part of a talk in a biology class.
All right, now a common misconception about global climate change, commonly referred to as global warming, is that if we experience an unusually hot day in this area alone, then it's evidence of climate change. I just want to take a second to make it clear that changes in local weather is a weather-related event, not a climate-related one. Climate refers to the long-term, predictable atmospheric conditions of a specific area, not the conditions of a day or even a week for that matter. Weather refers to the conditions of the atmosphere during a short period of time. Weather forecasts are usually made in 48-hour cycles and are more concerned with daily and hourly predictions. Yes, Henry?
So you're saying that climate has more to do with seasonal changes. For example, like the difference between summer and winter in New York, while weather is more about the conditions outside today or tomorrow.
That's right, Henry. So now that we have established exactly what we mean by climate, let me ask you about the causes of climate change. I mentioned them in the last class.
Well, we started by talking about the Industrial Revolution, which began in the early 1800s, and that's when most of society started burning fossil fuels like oil and coal. And those fuels release a bunch of carbon dioxide into the air, and when there's more carbon dioxide in the air, more of the sun's energy gets trapped in the atmosphere, so the climate of the Earth warms.
Perfect, Jessica. Maybe I should have you teach the class. So yes, most of us know about the harmful effects of the burning of fossil fuels and the release of greenhouse gases in the atmosphere, and I'll get back to that in a minute. But what causes climate change? There are two more. Henry?
I know one is solar intensity, and the other, I think, has something to do with volcanoes? Sorry, I can't remember exactly.
Well, like you said, the intensity of the sun does change, believe it or not. Changes in the amount of heat from the sun has been proposed as one explanation for past climate events. And the third you're thinking of is volcanic eruptions.
Ah, that's right. I remember now. The gases released during an eruption can change the climate over a period of a few years. But this type of climate change is usually just short term, right?
Right. Now, let's get back to fossil fuels. As Jessica mentioned, increased amounts of carbon dioxide and other greenhouse gases are usually released through the burning of fossil fuels. Make no mistake, what may sometimes be reported in the media as debatable, there is no debate among scientists as to whether or not climate change is due to human activity. True, the strength of the sun's rays and the eruption of volcanoes can play a role, but there is an overwhelming amount of evidence that human activity, particularly the burning of fossil fuels, is to blame for the rise in global temperatures. And we are now starting to see the tremendous impact global warming is having on our environment. Between 2002 and 2006, Greenland lost almost 200 kilometers worth of glaciers. And as the glaciers melt around the globe, the sea levels rise, which threatens the coastal life of humans and the marine life of aquatic species. Now, many organisms on land are also being affected by the changes in climate. Temperature and rainfall play key roles in determining the geographic distribution of plants and animals. For example, researchers have shown that 385 plant species in England are flowering 5 days sooner than usual. In addition, insect species that pollinate and rely on these flowers are now arriving sooner than in previous decades. This mismatched timing of plants and insects could result in the loss of both species in the area. Small changes in the atmosphere have already made a big impact on species that rely on specific weather conditions. Most think of polar bears and their disappearing homeland of snow and ice. But this is just one of the many organisms threatened by global climate change, and that includes us humans.
Now, answer the questions. 1. What is the professor mainly discussing? 2. The professor discusses several causes and effects of climate change. Indicate which information matches a cause or effect. This question is worth 2 points. Three. What is the difference between weather and climate? Select 2. Four. According to the lecture, what is an example of the effects of climate change? Five. What is the professor implying when she says this?
Perfect, Jessica. Maybe I should have you teach the class.
Six. What does the professor imply about the role of human activity in climate change? Now listen to part of a talk in an astronomy class.
Okay, so I'm sure you all know what meteors are, right? Those bright shooting stars in the sky that sometimes pass through the atmosphere and land here on Earth as hot rocks? Well, these alien rocks go on quite a journey to make it here. You see, these meteors start off as comets from other areas in space. The ice in these comets melt when they get close to the sun, which breaks apart and sprays millions of tons of rock and dust into the solar system. As each of the larger dust and rock particles enters the Earth's atmosphere, it creates a brief, fiery trail that is often called a shooting star but is properly known as a meteor. Since the particles move at speeds of many kilometers per second, friction with the air vaporizes them at an altitude of between 80 and 130 kilometers. The resulting flash of light fade out within a few seconds. To be visible, these shooting stars, or meteors, must be within about 200 kilometers of the observer. On a typical dark and moonless night, you can see up to 6 meteors per hour, maybe more. Now, I don't know about you, but witnessing a shooting star is really a magical feeling. Anyway, the typical meteor is produced by a particle with the mass of less than 1 gram, no larger than a pea. How can we see such a small particle? The light you see comes from the much larger region of heated, glowing gas surrounding this little grain of material. Because of its high speed, the energy in a pea-sized meteor is greater than a bullet being fired by a gun on Earth. But as I'm sure you all know, these shooting stars, these meteors, sometimes land on the ground. Meteorites are pretty much found in two ways. First, are meteorite falls. Sometimes bright meteors or fireballs are observed to penetrate the atmosphere and find their way to the Earth's surface. The 2013 Chelyabinsk fireball in Russia produced tens of thousands of small meteorites, many of them easy to find because these dark stones fell on snow. People sometimes discover unusual-looking rocks that turn out to be meteoric. These rocks are termed meteorite finds, the second way meteors are found. Since the 1980s, meteorite finds in the Antarctic have dramatically increased our knowledge of space and its materials. More than 10,000 meteorites have been recovered from the Antarctic as a result of the motion of the ice in some parts of that continent. Meteorites that fall in regions where ice accumulates are buried and then carried slowly to other areas where the ice is gradually worn away. After thousands of years, the rock again finds itself on the surface, along with other meteorites carried to these same locations. The meteorites in our collections have a wide range of compositions and histories, but traditionally they have been placed into three broad classes. First are the irons, composed of nearly pure metallic nickel iron. The second are the stones, the term used for any rocky meteorite. The third are the rarer stony irons, made, as the name implies, of mixtures of stone and metallic iron. Of these three types, the irons and stony irons are the most obviously extraterrestrial because of their metallic content. Pure iron almost never occurs naturally on Earth. Therefore, if you ever come across a chunk of metallic iron, it is sure to be either man-made or a meteorite. The stones are much more common than the irons, but more difficult to recognize. Often, laboratory analysis is required to demonstrate that a particular sample is really of extraterrestrial origin, especially if it has lain on the ground for some time and been subject to weathering. The most scientifically valuable stones are those collected immediately after they fall, or the Antarctic samples preserved in a nearly perfect state by the ice.
Now, answer the questions. 1. What is the purpose of the lecture? 2. What does the professor say about shooting stars? 3. Why does the professor discuss meteorites in the Antarctic? 4. What is the professor implying when he says this?
Of these three types, the irons and stony irons are the most obviously extraterrestrial because of their metallic content.
5. Based on the information from the listening, indicate which characteristic on the left belongs to either stones, irons, or stony irons. This question is worth 2 points. Six. Why can we see a meteor falling in the sky if it is smaller than the size of a pea? Now listen to a conversation between a student and a career advisor.
Hi, welcome to the Career Center. How may I help you?
Hi, my name is Michael. I'm a senior and I'm trying to apply for some jobs. I don't want to have to worry about finding something over the summer after graduation. I saw a flyer the other day somewhere on campus that said you were offering resume reviews and that I could just drop in whenever to get some help with my resume.
That's smart of you to get a head start. We do offer drop-in resume review, but that's only on Thursdays. And since today is Friday, of course you're going to have to come back next Thursday.
Oh no, really? Darn, I was really hoping to get some help. There is one job in particular that I want to apply for, but the deadline is next Tuesday, so I need to get help with my resume before then.
Well, what I could do is make you an appointment to meet with the career advisor. That will be better anyways, because then you can meet for an hour or so and discuss any questions you may have.
That sounds amazing. When do you think I can get an appointment?
Let me take a look at our calendar here. Ooh, I hate to say this, but it looks like all of our advisors are fully booked until Wednesday.
No one is available until Wednesday? Yikes, that's too late also. I mean, I guess I could make an appointment anyway since I'll be applying to other jobs in the future. But what should I do about this one? I have no idea how to write a good resume, and the job application is due Tuesday.
Why don't I put you down on the wait list? So that way, if anyone cancels or something opens up, I will call you right away. In the meantime, you could try having a friend or family member help you out, or talk to someone you know who has written a resume before. That's probably your best bet.
Yeah, I guess I'll have to do that. Well, thanks anyway. And please put me down for the appointment on Wednesday.
Will do, and I will call you if anything opens up sooner. Have a great day.
Now, answer the questions. 1. Why does the student go to the Career Center? 2. Why is the student upset that the resume review is only on Thursdays? Three, why does the student take the appointment with a career advisor on Wednesday, even though it is after his application is due? 4. What will the student do since he is unable to get help from the Career Center before his job application is due? Five. How does the student feel after his conversation with the Career Center receptionist? Now listen to part of a talk in an American history class.
So, America looked a lot different back in the early 19th century. Most Americans lived on the East Coast, populating cities like New York, Boston, and Philadelphia. However, there was still plenty of land west across the Mississippi and stretching all the way to the western shores of the Pacific Ocean, in areas around present-day California. The American government wanted to get people to start moving out of the East Coast and migrating west to settle these lands and create new villages, towns, and settlements. The Homestead Act of the 19th century gave free land for any brave pioneers who were willing to migrate west and settle in the plains lands in modern-day states like Kansas, Nebraska, and the Dakotas. Now, of the hundreds of thousands of settlers who moved west, the vast majority were what we call homesteaders. These pioneers were mostly average families seeking land and opportunity. Free land sounded like a great deal to many recent immigrants who had difficulty finding work and had hardly any money to their name. The promise of a piece of land to raise a family and call home sounded too good to be true. And it was. You see, there was a reason why most of this land remained unclaimed. It was unsettled and hard to farm. Still, the idea of a new life was too good to miss for some. They settled throughout the land that now makes up the Midwestern states of Wisconsin, Minnesota, Kansas, Nebraska, and the Dakotas. The weather and environment was terrible, and settlers struggled to make out a living. The region typically had low rainfall, and harsh temperatures made the growing of crops almost impossible. Irrigation was a requirement, but finding water and building adequate systems proved too difficult and expensive for many farmers. The first houses built by Western settlers were typically made of mud and sod with thatched roofs, as there was little wood for building. Rain, when it arrived, presented constant problems for these sod houses, with mud falling into food and pests, most notably lice, living in the bedding. Weather patterns not only left the fields dry, they also brought tornadoes, droughts, blizzards, and a huge amount of insects. Farmers also faced the ever-present threat of debt and farm foreclosure by the banks. While land was essentially free under the Homestead Act, all other farm necessities cost money and were initially difficult to obtain in the newly settled parts of the country, where market economies did not yet fully reach. Horses, farm animals, wagons, wells, fencing, seed, and fertilizers were all critical to survival, but often hard to come by since so few people lived in these areas. Railroads charged high rates for farm equipment and farm animals, making it difficult to get goods or make a profit on anything sent back east. Banks also charged high interest rates, and in a cycle that repeated itself year after year, farmers would borrow from the bank with the intention of repaying their debt after the harvest. As the number of farmers moving westward increased, the market price of their produce declined, even as the value of the actual land increased. Each year, hard-working farmers produced ever larger crops, flooding the markets and then driving prices down even further. Although some understood the economics of supply and demand, none could control such forces. Eventually, the arrival of a more extensive railroad network aided farmers, mostly by bringing much needed supplies such as lumber for construction and new farm machinery. In turn, larger commercial farms began to develop. Farmers in Minnesota, North Dakota, and South Dakota hired migrant farmers to grow wheat on large-scale farms. These enormous farms were succeeding by the end of the century, but small family farms continued to suffer. Although the land was nearly free, it cost close to $1,000 for the necessary supplies to start up a farm, an impossible sum for most. Many people who were drawn out west for free land ended up as hired workers, working on other farms for a daily wage. The frustration of small farmers grew, ultimately leading to a revolt. But I'm getting ahead of myself. Let's take a closer look at.
Now, answer the questions. 1. What is the lecture mainly about? 2. What was the purpose of the Homestead Act? 3. How does the professor organize the lecture? 4. Why does the professor talk about the farmers' homes? 5. Why did many farmers end up needing a large amount of money to succeed in the new land? 6. What eventually led to the development of larger commercial farms?